Hello. Hi, Tara. Hi, Vinayak. Guys, we are on live now. So, Tara, could you please, 1 second. Yeah. Could you please share your screen?
Hi, sir. Good evening. I'll share now.
Yes, please. Yeah, Vinayak, we are live on YouTube. Just share the links across to all the students that they will be able to join.
Yes, we have sent the mail.
All right. I mean, this one.
Yeah, the new link.
Live stream URL.
Yeah.
Okay. All right. Right. So I think the anybody who joins on YouTube, so they can actually go back and check the videos as well. I think we should be good to get started with the session ahead from here.
Okay, sir.
Yes, sure. So we'll get started. By the way, hello everyone. Good evening to all of you. Thanks a lot for joining for the day 2 of Automotive CAE Bootcamp. As a part of this session today, we'll be continuing the hands-on activities. I believe you all have enjoyed yesterday's session that was done to cover up the fundamentals of FEA and also, I believe, the basic GUI introduction. So in today's session and continuation to tomorrow, we will be further streaming for all the hands-on activities. I believe you guys have the software with you to practice ahead of the session. So with that note, I'll hand over the session to Tara. Over to you. Thank you.
Thank you, sir. Hello, all. Welcome to CAE Bootcamp. Welcome back to the CAE Bootcamp. Today, in the module 2, we are going to discuss about the 2D machine. Yesterday, we have discussed about the fundamentals and the basics of finite element analysis, like what is the finite element analysis and the introduction to HyperMesh. We have gone with the HyperMesh window and we understand what are the toolboxes are available, what are the menu pages are in the HyperMesh and working panels, what are the basic geometry cleanup or topology cleanup that we can do for any CAD before we processing for the machine. In continuation to the module 1, today we are going to take one component, and for that component we need to extract the mid-surface and the topology refine. After extracting the mid-surface, what are the things to be done before it taking for the meshing? In the meshing, what are the elements are available in HyperMesh and what is automeshing? After the meshing, we are as I said, after the meshing we need to clear the quality parameters. What are the quality parameters and what are the ranges of that one? We learn all these things in the today's session. And the tomorrow's class, in the tomorrow's session, we are going to conduct on the 3D machine, where you are going to build your 3D component or 3D machine you are going to build. In the today's class, I hope you already received the component from Decibels. And I think you are already have installed the HyperMesh software. It's good to have the tool so that you can practice with me. Let's start our session. See, as you can see in the image, which I am displaying here, This is the CAD file which we have shared, and this is for this component you guys are going to mesh this one. So as you can see, this is one of the plate component having so many ribs and having some circles with it, and this is a plastic one. There is a difference between the plastic component and the sheet metal component. These two components, we are going to do the 2D meshing. Let's learn what are 2D meshing, why it is required, and why it should be in the mid surface only. Let's learn one by one. And the first image in the left side, what you can see, this is the CAD file or the geometry file, which is built in the design software. And the right one you are seeing, this is the finite element model, that where I have used the two kind of elements, which are the quads and the tri-elements, to complete this meshing. To finalize this one with all the things and with the quality cleared elements which you are seeing. And this is built in the CAE software. That is the HyperMesh, the software which I have used is the HyperMesh. And I hope you are already having these CAD files with you. Let's start one by one. See, these are the today's agenda that I am going to discuss starting from the editing the geometry. And in the last session, we know why to do the geometry editing. So why it means yesterday we have learned when the geometry is having a discontinuous or missing surfaces or any extra surfaces or some features may what happen when you are bringing some CAD file from the designing software to the CAE software. Because of the software compatibilities, there may be missing surfaces or there may be extra or less surfaces. So these things may arise because of the software compatibilities. So that thing we have to take care before extracting the mid surface. So in the mid surface, I'm going to show what are the mid surface options are available to do for the 2D meshing. Then later on, we'll start doing the meshing, we'll clear the quality parameters, and we'll learn how to assign the thickness. Since we are doing the 2D meshing, we are going to assign the thickness. So what is the thickness, how to assign that, we'll learn one by one. See, first we'll go by starting the mid-surface extraction. See, as you can see in the image, see, this is the image which we have shared, and this component is also you guys are having in your PC. See, before extracting the mid surface, the basic idea is to first I want the geometry should be cleaned because I'm going to extract the mid surface. The mid surface plays a very important role when you are doing the 2D meshing, because on the extracted mid surface only we are going to build the element. We are going to create every element on the mid surface. So you can ask me, she got some component and she's telling to extract the mid surface. Why to extract the mid surface? Basically, when the component having a lesser thickness, when the components having a more ribs or the more features, when the thickness, see, as you can see here, this is the length of the component and this is the width of the component. When these two are comparable, then we will go by doing the 2D meshing. To do 2D meshing, we require the mid surface. On that mid surface, we will create the element, then we will assign the thickness. What is the original thickness of this one? See, here the thickness of the component is 3 mm. So 3 mm we are going to assign to capture or to cover for this complete component. This is a basic idea why to extract the mid surface. We are doing the 2D meshing. Obviously, we need to extract the mid surface. If the mid surface, after extracting the mid surface also, we need to do some geometry cleanup, some topology corrections, everything we need to do. First, I go by extracting the mid surface. See, this is a shaded. I have kept my geometry in the shaded mode. See, you can rotate it to any views if you want. Let's keep in isometric view. See, these are the views which are available. You can keep it in any view, the front view or top view. See, you can keep however the views which are comfortable. Okay, to visualize the geometry, I am keeping this geometry in a wireframe. See, this is a wireframe model. As the name indicates, the wireframe model, it contains only the lines. It is not showing the surface. If you keep it on a shaded mode, you can see the surface. Okay, we'll go by extracting the mid surface. See, the mid surface option is available in the geometry page. We know there are the different pages which are available in HyperMesh. I'm going with the mid surface. Click on this mid surface. If you come for mid surface, this is a sub panel for the mid surface where you can see there are the different options to extract the mid surface. You can go by auto mid surface. Auto mid surface means software will give the automatically the software will give or will generate one surface, or else manually also you can generate the mid surface using these two options. Now I am going with the auto mid surface. That means I am asking my software to extract the mid surface. But in this also, I'm having a few more options that are extraction option. It means how you can extract the mid surface. These are the 4 ways to extract the mid surface. I'll just go by one. See, I'm keeping in an auto mid surface. Here I have kept offset, planes plus sweep I'm using. How it works, we'll see one by one. Just click on the surface. See, in a one single click, the surface has selected the complete. Since my component is in complete volume surface, this is a complete volume surface. As you can see, as I said, it doesn't have any free lines or any free edges or any duplicates or any triple lines. It doesn't have. So in a single click, all my surfaces selected, and when you are extracting the mid surface, it should select like this only. Just click on the left button, everything will get select, say extract. If I click on this extract option, please observe in the status bar. Please observe in the status bar that it will show how much percentage has done. Now the 75% of mid surface extraction is done. Now it's telling it's ready. See, we'll review the mid surface. This is the mid surface which we got. And as I said, it is not mandatory to get a perfect mid surface. It is not mandatory to have a perfect mid surface. We have used the option called offset planes will please sweeps. How it works? It works if you are using the sweep option. It works good with these kind of surfaces. This kind of curved surfaces, it works well. Then the offset means, as the name indicates, offset means I am just keeping one surface in between the two surfaces. In between these two, see, as you can see, this is the top surface and this is the bottom surface. I'm just offsetting. It means I'm just creating one surface in between the two main surfaces. That is top and the bottom. As you can see here, some of the red lines has created. That means I have created one surface in between these two. See, like this, it has created. Now we'll try one more option. In the extraction option, I'm keeping only the offset I'm keeping. Click on the surface, say extract the mid surface. It will take a seconds to get extract the mid surface. It will take only the few seconds and it depends on your system configuration. Now switch off the original component and we know here the components are visible. This is the flag symbol. That means it contains geometry. It is the 4 element symbol which you are seeing. It is the element representation. The flag symbol is for geometry and this 4 element symbol is for the element representation. Now I'm switching off the main component. Just switch off this one. Now observe now you can observe the surfaces. Say the first one which we have used, that is the option with sweeps we have used, but now I extracted the mid surface using only the offset option, and I feel the offset option work well with this component. So this is a mid surface. So this is the basic idea to extract the mid surface. You can switch on your original component, and you can see in between the green lines, in between these two green lines, you can see the one more color, that is the red one. See, you can observe the red lines. It means the mid surface in between the surface. And the mid surface, what you are going to create, that it should be on the exactly in the mid plane. If it is not on the mid plane, your mesh will go wrong. See, exactly, I have created the 3 nodes. I have just created the 3 nodes on this line. You can see on that mid node only my mid surface is there. You can check it in anywhere you want. See, I'm just where I can see the better way. See, I'll just create some of the nodes here on this line. So create, see exactly on this node, only my mid surface is generated. So this is how the idea to extract the mid surface. After the mid surface, as I said, I am going to create my elements on the surface. I'm going to create my elements on the surface only. Then you can ask me, like earlier we are having a complete volume surface. Now we have extracted, and you can see this is a single surface. This is a single surface. You just observe, this is not on two surfaces, this is a single surface. See? If you click on any surface, only the single surface is selecting. But our component is having two surfaces. It is having the two surfaces. And after creating the elements, we are going to assign the thickness for this component. After assigning the thickness, we'll see how it looks. And as I said, after extracting the mid surface also, we need to do some of the geometry correction. Why we need to do, I'll tell you. See, as you can see here, the rib, as you can see the rib, this is called the rib. See, this is a square rib and this is a rectangular rib. These are the rib. There might be a square, rectangle, or a triangular rib. So why we need to do, just if the surface is very bad and if I go and create any elements, I'm just showing, see, I'm just selecting the surface and asking to mesh, see how bad the elements are. And for this surface also, choose this surface and mesh this one, see, it is in good planar surface, so I got in good elements. But if the surface is not good and the surface, we are not required, we don't require this surface. So this is the geometry correction. This is called the geometry correction. And one more thing, in the geometry corrections, we need to check all over the component. Not only for this surface, for complete component, we need to analyze it, whether the extracted mid surface is correct or not. That we need to check it. So we'll check one by one. What I'm going to do, here I am going to delete the surface. See, first I'll delete the surface, then I'll recreate it. How to delete it? And we know for the deleting option, which is available in the functional key F2. If you go for functional key F2, see, if you draw in this drop down, you can see these are the options which we can create. We are having the option to create, means then there will be an option to delete that one. See, here the surface is there. Click on this surface and I'm deleting this surface. I don't require that. See, now how the surface is. Now the surface has become very smooth and planar. And here also, this is also I'm not required. So like this, you need to delete it. Delete it means like in a random way, it is not supposed to delete. It should having some sense that you are going to delete the surfaces which are not required. Now we can observe this rib, how smoothly the rib is. Now if I go and create the elements over here, I can get the good flow of elements. Then this is one type of correction. And if you come over here, see, these surfaces are not connected. The surface is not connected. We need to connect this surface. See, in this periphery icons, one option is there, this one, to switch on the points. And in yesterday, we have discussed what is the difference between node and points. These are the gray ones are called nodes and the yellow ones are the points. Now see, the surface is not connected. So I need to connect it. How to connect? I'll go for quick edit. That is in the geometry page. In the geometry page, you can see the quick edit option. Click on that quick edit. Here the option is called replace node. So replace node option is there. I'm just going with this and I'm replacing this node to here. I'm just connecting these two and this to this I'm connecting. We select this node and connect it here like this and choose this node and place it here. So this is how you need to connect it. See, the ribs are not connected. So I have created a rib. And see, here there is a green line that is sharing between the two surfaces. Here the red line is there. It represents there might be in free edges or that might be any circles in the geometry. But whereas here you can see the yellow line. That yellow line indicates this surface is sharing between the three faces. This line is sharing between the three. That is, this is one surface This is one, the second one, and this is the third one. So the yellow line indicates it's sharing between the three surfaces, or it might be a duplicated surfaces. See, here and all, you can see the green lines, that it means it is sharing between the two. But here, no, you can see that is the, when the ribs are coming, then it's going to share with the two surfaces. This is a basic idea, the geometry representation. We know how to clear the surfaces, and we know how to give the connections between the surfaces. And one more thing I wanted to tell, when the holes are coming or when the circles are coming, we are going to create some washer to it. This is also, and this also comes under in the geometry cleanup section. So why the holes are required? To represent any bolts or any nuts, screws that you can see in any of the automotive component that comes with a washer that you have seen. One plate, one round plate will come along with any nuts or any bolts. To represent that, we need to create the washer. That means I am going to represent my FE model with the, if it is a bolt hole, I am going to represent with a one more washer set of elements to represent it. Okay, it representing M8 or M12 or something like that. What is the diameter of this one? According to the diameter, I am going to create the washer. How to create the washer? I just go for the quick edit. See, this quick edit option plays an important role when you are doing the geometry cleanup. See, every option, if you are doing for meshing, the F12. If you are doing for geometry cleanup, that is the quick edit option will work. If you are doing for the 2D meshing, that the mid surface plays an important role. So like this, there are the very important keys that we should know. Here, I'm interested to create in the washers. See here, I don't know whether it is a normal hole or a bolt hole. So how to do that? I'll just go and I'll create some of the nodes on this line and just measure this one. The measuring option which is available in the functional key F4, just measure the diameter or the distance between these two nodes. You can see the distance is 30. Then it is an M30 bolt. So we need to represent like that. Then what to do? I'm going to create some washers. Come for the quick edit. Here one option is there, washer split. Here you need to give the washer size or the offset value. See, I have created the washer. If it looks very small, you can increase the washer size. So you can see, you can increase the washer size. What I'm going to do, according to with this midpoint only or this circle center, I am going to create one more circle which is bigger than the diameter, which is 2 times bigger than this circle. Why? Because I need to represent the bolt. I need to represent the nut. So to do that, I have gone and I have created the sum of the washers. These are the very important, the mid-surface checks we need to do. We'll move on to the next slide. And see, in the mid-surface, we have learned using the sweeps and using the offset. We have seen by how to do the extractions. Next, now our mid-surface is clean. Now we'll move on to how to create the elements or how to do the meshing. Basically, the idea is to do meshing. Why? Because, see, as you can see in this image, if I'm interested to create only the elements for this portion, means, as we know, the finite element analysis is doing the calculation that is infinite degree to the finite degrees. Here you can see, I don't know how many number of points are there. And if I don't know the number of points, I know the degrees of freedom, but total equations I cannot define. I cannot define the total equations. Whereas I can bring this problem to the finite element analysis. I am dividing the surface with 8 nodes. See, 1, 2, 3, 4, 5, 6, and 8. I am dividing the surface using 8 nodes. So 8 nodes are there, means I know there are 6 degrees of freedoms are there. 3 is translation and 3 is rotational. So totally I can 8, 6 is 48. I can define the number of equations. We have did in our academics, like in the finite element subject, there to how to do the equations or how to calculate the number of equations for a particular surface, or when you are working for the truss component or in bar component, we have calculated the number of degrees of freedom or all those things, the stiffness and extracting the natural frequencies and all, we have done based on this number of nodes and the number of degrees of freedom. Based on this, we have calculating. Likewise, the software will work also in the same way. It will calculate according to the how many number of points in the CAD or how many number of points in the element multiplied by degrees of freedom. then it will define internally. It can define the 48 equations that it can define. See, here I have mentioned any continuous object has infinite degrees of freedom, and it is not possible to solve in this format. See, we cannot define any solution, and even the software also cannot define anything if you are not defining the number of nodes and the elements. So the finite element reduces the degrees of freedom from infinite to finite with the help of meshing, discretization, or dividing using nodes and the elements. We know the number of nodes and we know the degrees of freedom. So the even internally it will define, okay, 48 equations will come. According to that, it will give the solutions. So this is the theory behind, or this is the work nature behind the software, and the same we are using in the academics also. Next comes to the 2D elements. See, basically we are having two shapes of elements. That is, one is a tria shape and is a quad shape. And in the 2D, we can see only the tria means there are 3 corner nodes, whereas quad means it is a 4 corner node. This is a 3 corner node and this is a 4 corner node. And this tria is subdivided into 2. That means this is a these are a single degree of freedom, and this is second order element. This is the first degree of freedom, that it means only the corner nodes are selecting. The corner nodes are selecting, whereas in linear triangles or in the second order, we can see there is a mid node between these two. There is a mid node between these two. Likewise, the quad is divided into 2. The 4, this is a 4 corner node with 4 noded element. This is an 8 noded element. And how these two will differ now? Based on the project requirement, we are going to use these kind of elements. When we are looking for a very accurate results, if the system capacity is more, then we are going with the second these are mid node or the 6 corner nodes are the second order elements. If you are looking like even, but using for the second order element, you need a higher configuration system, and it will give you an exact answers. Compared to these two, you will get a very accurate results when you are using for the second order element. Unless it is not defined in the projects, we are not going to use the 2D elements, second order elements. This is a basic idea between the element shapes. Next, we'll move on to the Automesh. Like we know how to do the elements, what are the elements, and we know why to do the meshing, and we'll move on to the Automesh. What is an Automesh? There is an option in the F12 called for Automeshing. There we are going to choose the surface, and we can edit the mesh also. And here you can see the number what you're seeing. This is the element size. It means I'm going to define some surface using this, or based on this number only, my surface is going to generate the element. See, here I have kept the mixed mode option. See, in the mixed mode, you will get the element like this. One is, as I said, only the 2 kind of element you can see. Only the 2 shape of elements, that is the 3 are the 4 corner nodes. We'll see in one by one in HyperMesh. See, just press on the functional key F12 option. You can see this sub window. You can see this window where you can select a surface like this. If you are interested to create the element on the surface, you just click on any surface you want, it will get select. Or else in a single window, you can select all the surfaces, it will generate the mesh. And after generating the elements, in this drop down, you can set for the elements to do any remesh option, set for the elements. And here the number, see, you can give any number based on your project requirement. You are going to define this number. I'm keeping it as a 4, means I'm just selecting this surface and I'm meshing this one. See, according to this, the value which I'm giving, that is the element size, it is going to build the elements. If I change it to 10, just observe the elements. See how the elements are. It means the number of, if you are increasing the element size, obviously you will get a less number of elements. Why? Because it will acquire this geometry, or it will divide this geometry by, it will divide the geometry to create the elements using 10 mm as the element size. It means you can see, you can observe it, it will be 10 only, more or less it will be 10 only. So this is how the element element size will work. And over here, if you are selecting only the mixed option, it will come like this. Whereas if you are keeping only the trias, see, only the tria element will get generated. You will not see any quad element. All over the surface, you will get only the tria element. Or if you are interested to create only the quads, see, only quad elements it will generate. See, this is a 4-corner node only. This is not a triangular element. This is a diamond-shaped element, or we can call it as a rotating quads. It is unable to generate even in one tria element. See, you can observe this is complete surface. You will not find any trias. But based on the project requirement, we are going to use the mesh type or element type. Generally, the mixed mode we are going to keep. See, generally, we'll keep the mixed mode only to generate the elements. See, like this, we will generate the elements. This is how the the mixed mode will work. Then we'll choose some surface and we'll do the meshing for that surface. See, I'll choose this surface. I have kept it in a mixed mode. Here, we'll create one collector. How to create the collector? Yesterday, we know, go for model tree. You can create any collectors like this, or else in the periphery icons, you switch on this, the blue one. It will ask you to collector name. I'll give it as a some rib, like I'll give it as a rib. Why? Because I'm interested to create the elements on the rib. Here, where you can go and create the property. Property means assigning the thickness. How to assign the thickness? How to view the thickness means go for mid surface. In this drop down, there is an option of review thickness. If you click on this surface, see, it will show the thickness is 5 mm. And if it is the thickness will vary from surface to surface. If you click on the surface, it is showing 3. See, the number is going to change. If I click on this rib, it is showing the 5. But the main surface is having a thickness of 3 mm. But the thickness will vary. So we need to create a separate thickness. How to create it? I'll show you. I'll create one component. I'll create the component, some rib I'll create. Then property I need to create a property. Here the 2D, why on the type I'm keeping as a 2D. Why? Because I'm interested to create the 2D elements, and the card image as special. I'm generally for creating any 2D elements, generally we are keeping the special elements. Say create edit. Here there is an option called T. It means we need to assign the thickness. You just click on this one and assign the thickness. It is 5. I'm just giving the 5. 5 means I'm just assigning the thickness. Say create edit, say return and create edit. There is a new component got created. I'm just changing the color of this one. Say component got created. We learned how to create the component, and we learned how to review the thickness and how to create a new property to the collector. Now you come over here and switch, click the surface. Say mesh. See how good the mesh is. We want elements to be like this. As I said, if you decrease the element size, see, you will get very fine elements. So you will get according to the element size which we are going, according to that it will work. See, this is how it will work for the neat surfaces. But what if you are having a very bad surface? See, I'll choose this one. I'll mesh this. See, okay, this is not a bad surface. Just observe, here we didn't find any trias, but here we can see there are many trias are there. How to reduce the tria? See, here in this drop down, I'm switching to the elements to do remesh. See, select the elements. See, you can select by window, or else you can go and select by one also. You can select like this, or like this also you can select. In a complete side also you can select. See, here I need to reduce the tria. See, you can ask me why to reduce the tria. We are allowed to keep only the 5% of the tria element in a complete model. That means, say for example, if your model contains 100 element, out of 100 element, you can keep only the 5 trias. Why? Because the tria element will add more stiffness to the component. Then the component will become stiffer. If it is a more stiffer, we may get less stress values, and we may get a lesser displacement also. For this reason, we are not allowed to keep more number of trias. That is the restriction to the 5% only. Now I have selected the element and say mesh. See, the new elements got generated. So how to correct this one means, here the number 11 is there. You go and just click on this one. It will increase if you are clicking the left button. It will decrease if you are clicking the right button. See, this is the remesh I am doing. Why we need to do the remesh? To get the proper elements, I am going to do the remesh. See, this is how you can edit or you can create the elements. See, this is how you need to create or remesh the elements. Like this, you can select and you can do it. You can select one by one. See, you do need to do like this. See, just observe it. I'm selecting these surfaces. I'm selecting these surfaces to do remesh. Just I'm selecting these elements. You also need to select like this only. If you click on this one, this is called the density of the element. See, I'm reducing the density. Here also I'm reducing the density, and here too. Why? Because I'm trying to reduce the number of trias. See, here you select it. See, manually, where and all you required a neat elements or a good elements, you need to come here and do the manual mesh or remesh you need to do. See, like this, everywhere, where and all, sorry, where and all you require, you come and you need to mesh like this. See, now I have reduced the few trias, and even more trias, if you want to reduce it, see, you have to mesh like this. Select the elements and complete the mesh. See, you can do like this. See, based on the number of density, based on the density only, it will work. So you need to work on this to reduce the density, and the flow also, it is mandatory to maintain the good flow of elements. Then it comes to the washer side. See, in the washer side, especially when you are representing any bolt, if it is a normal hole, not to worry, we are going to keep the even number of nodes. But when it is the washer elements, first choose the washer like this and you mesh this one. See, here 33 is there, here 24 is there. We need to match these two elements. We need to match these two elements. In the washer, we are not going to keep any trias. Don't keep any trias inside the washer. As I said, tria, if you are keeping means, it will add the stiffness to the component. If this component is stiffer, we will deviate from the original results. So for the washers, you need to mesh like this. See, here I'm matching, there should be a matching node. There should be a matching node between the washers. It should be mandatorily to have a even number of nodes in the washers. See, like this, you need to maintain. See, like this, you need to maintain. You need to mesh this, you need to mesh the component. See, this is the component which I have completed the meshing. As you can see, I have captured with the 2 rows of elements. See, here and all, I have captured it, and see, I have completed the meshing of this component. See how the element flow is. We need a element flow in a proper way, and it should be aligned, and it should be the capture featured. It should be captured with all the features. It should be captured. Now we know how to create the elements, and we have built some elements on the mid surface. Now we'll move on to the quality checks. What are the quality checks? See, basically consider any geometry. For example, when you are working on any square box, obviously you will get a good flow of elements. That means when you are working on a square shape like this, you will get very neat elements. But what happens when you are working like this, when the components or elements are little, it is having a little deviations from the geometry, or like this, see, it is deviating from the geometry. Basically, to do the why the quality requirement is required is, all the way we are unable to keep the exact shape of triangle and the exact shape of any quad element. Some way we need to match with the geometry, and we are creating the elements which are not an ideal shape. Which are not an ideal shape means that is in square. Ideal shape of triangle is equilateral triangle, that is a 60 degree and for the 90 degree. If you are unable to keep these two as a perfect shape or ideal shape, then we are going with a certain defined parameters. All your elements should be in that defined range only. What are the ranges? What we call it in a CAE industry or in HyperMesh means, see, this is what we are going to check. For the 2D panel, we are going to check the warpage, aspect, minimum and the maximum length, Jacobian, minimum and the maximum angle for the tri-element, minimum and the maximum angle for the quad angles. The idea of using a quality parameter is all the way or throughout the component, we are unable to keep the perfect shape of the elements. To match the CAD, we are deviating from the ideal shape or the perfect shape, but the deviated element should be within this defined range only. So how the quality parameters will implement, we'll see that in HyperMesh. See, as you can see, the quality parameters is available in the functional key F10. If you go and click on this functional key F10, see this window will appear, this panel will appear. In this, the values which I have given, 15 the warpage and aspect 5 I'm giving, and the minimum length, this is the minimum length, it is 2 mm, and the maximum length I'm keeping 5. Here the 20 is my minimum angle and the maximum angle is 120. And the minimum angle is 45 for the quad element and 135 for the quad element. Maximum angle is 135 for this quad elements. And all my elements, no matter how many elements are there, how many components are there, all your elements should be within this range only. We'll see how to clear one by one. You just click on this component. See, there are 10. You can observe in the status bar. Observe in the status bar, there are 10 elements are failing. Here it will show 15,667 elements are there. It is the element count. For complete this component having around 15,000 elements. Now 10 elements are failing. We'll see one element how to clear the warpage. I'm just saving the failed elements. Just go for F5, retrieve the elements. See, I have taken only the failed elements. Come for F10 again, click on the warpage. See, if you click on only the single element, just click on the single element, it will show the angle is 15 degree, it is showing. So we need to make it for 15 degree only. It should not be more than the 15 degree, and it will show all the details. See, warpage, aspect, it will show, warpage, it will show, Jacobian, it will show. So you can click on any element. See, you come and you click on here. Here it is showing the warpage is 0, means this is a perfect shape of element. But here it is showing some amount of degree deviation because to match the CAD, to capture the CAD. So what is an warpage means the element not being in planar shape, that is called the warpage. How to clear the warpage or how to clear the quality? I'm just translating one node. I'm doing the shift F4 and I'm translating this node. See, now it has become the warpage value as 14.75. So like this, you need to clear the quality. For this element warpage, we have reduced to 14.75. So now with this element is within the range, this element is passing for the quality. So like this, you need to clear the quality for all the elements. You need to clear like this. Next, we'll check for the aspect ratio. In the aspect ratio, I'll show you how the aspect ratio will work. I'm making for 1. Now come here, F10, and check the warpage of this element. See, warpage, it is showing 4.99. Let me reduce even more. I'm making for 0.5, the distance between these two nodes. F10, to click on the warpage. See, now warpage is failing. Sorry, aspect ratio is failing. Click on the aspect ratio. See, these two are highlighting. These two elements are highlighting. Why? Because these two elements are failing for the aspect. Aspect means maximum element length to the minimum element length. So how to clear it? Go for F7, align these two nodes. Just say align. See, now it has gone. We learned what is an warpage, what is an aspect ratio, and another important is what are Jacobians. See, Jacobian is a very important one. We will look for the quad element. We will look for the quad element. See, this is failing for the Jacobian. And how to clear the Jacobian and all. See, in the 2D page, there is an option called quality index to clear the quality very easily. Click on this one. Here, see, I'm just placing the node like this. If it is red means it is a dangerous element. It is in a yellow means it is in the borderline, and the red means it is a failing element. The other elements what you are seeing, these are the quality passed elements. So like this, you need to clear the quality. Manually also you need to create a manually you need to correct it, or else by using the software, by going to the quality index also, you can clear the quality. And the other important things are, see, the minimum element and the maximum element. See, there are 7 elements are failing. See, here the elements are failing. We need to align the quality. And the Jacobian, the definition of the Jacobian is element is not being an ideal shape, or else how much the element is being or deviating being an ideal shape. It means, see, here and all it is in perfect square. See, even the Jacobian it is showing. The Jacobian, important in the Jacobian is element should be 100%. But whereas if I come over here and if I click on this for this element Jacobian, it is showing it is matching only the 70%. It is matching nearly, it is matching only the 70%. So the idea of the Jacobian, I am making this component at least it should match with the 70%. At least it should match with the 70%. So this is the definition for the Jacobian, and the angles, the triangles and the quad angles also we will check it. See, if you go and click on this one now, it will show the angle. See, the angle is, it is showing 144, but we need to maintain 135. So how to correct this one means, go for F4, you just measure the angle between these two. See, here you can see the angle. See, here you can see the angle of this one. See, here one I'm making to 134.99 I'm making. See, now I have cleared the angle for this one, but this one is not completely cleared. I have just cleared the angle for this one. So this is how we need to clear the quality. So warpage, aspect, minimum and the maximum length, minimum and the maximum angles for the tria and the quad angles. Along with it, we learned how to clear the quality for the Jacobian also. Now we'll move on to the next slide. That is, what are the additional checks we need to do? Additional checks, say for example, we need to clear the free edges. The free edges in the sense, all your elements should be connected to each other. All your elements should be connected to each other. See, if you go and check the components, see, there is a free edge. Why? Because I have deleted the elements. So this is called the free edge. In a complete assembly of component, every node, each and every node should be connected. If it is not connected means it will throw an error. It will show a different values. We will not get an exact value what we are looking. So for this is the reason clearing the free edge is an important check. It's not an important, this is a mandatory check that we need to do. This is also an additional quality check for the assembly. The other thing is, in the F10, we need to check for the duplicate elements also. Why we need to check the duplicate elements? Say for example, you are having 100 elements. 100 elements you are having, but the same 100 element, say for example, it is having 100 element means, again if it is duplicating means it become a 200 elements, then the component become very stiffer. Again, if the component is stiffer means there will be less stresses or less deformations. So for this reason, carrying a duplicate elements, it is dangerous to carry the elements. The other thing is, we need to assign the thickness, we need to capture the geometry, and the normals also we need to adjust. What are normals? The element normals, the option is available in functional key Shift F10. You just observe I've just selected all the elements, say display. As you can see here, there are some red and there are some blue lines also there. So what we need to do in the normals, we need to keep all should be in a one color. See, it should not be like this, even though it will not affect that much for the, it will not impact so much, but this is one of the mandatory check we need to do. How to do it? See, I'll show it for one element by face I'm taking, display, say reverse. So again, I am displaying all the elements. See, now I have corrected this one. I have corrected this one. I'll show it for one more. Elements by face I'm taking, display, say reverse. Elements displayed and display normal. See, it has corrected. Sorry, it has not corrected. Say reverse. Now check all with all the elements. See, now it has selected. So like this, you need to correct it. You need to correct for all the complete component. Next, the important is how not to mesh. How not to mesh means, meshing means it is not like randomly going and creating the sum of the elements and telling that, okay, you have completed the component or you completed the meshing without the quality and all. Even though sometimes what happens, you are clearing the quality, but the mesh is not good. Element flows are not good. So what is that? That means how not to mesh. See, you can see in this image, single node is sharing between the two tria element. The single node is sharing between the two tria element. This is not allowed to mesh like this. And you can see these are the back-to-back trias. These two, this is the opposite trias. It is pointing towards each other. We recommended the mesh like this. The last image, which you can see, we recommend this mesh. The next is on the fillet, we are not supposed to keep any trias. On the trias, we are not supposed to keep any trias. And when the geometry borderline also, we are not going to keep any trias. See, it will, I'll show like this. See, these are the back-to-back, these are the opposite trias. This is called the opposite trias. And these two are what you are seeing. This is an opposite tria and back-to-back tria, both are together. And if you come over here, the single node, this is single node sharing between the two trias. See, this is a single node sharing between the two trias. So these kind of elements we are not supposed to keep. How to correct this one? The first thing is go and remesh the component. See, go and select elements and remesh it. See, now we are recommended the elements like this. If it is not remeshing is available, in the remeshing, if it is not going means you come and do manually. See, like this, I'm requesting for the quad element. So like this we want. And one more is near the washer also, we are not keeping any trias. So what we need to do, we need to swap this edge. So we need to swap this edge and clear the quality. So near the washers also, we are not supposed to keep trias. And here, see, especially in the geometry borderline, also, we are not supposed to keep any trias. This is not recommended. Why? Because we are in the geometry borderlines. This is not allowed. And as you can see here, the flow of lines is not good. The flow of lines are not good. Either you can go by doing the remeshing, or else the one more is smoothing the elements. So how to smooth the elements? Go for functional key shift F12. Here the iteration I'm giving is 10 and select the elements which you want to smooth. The smoothing, how the smoothing option work now? Just it will try to adjust the element between this highlighted element. Between the highlighted element only, it will try to smooth. See, in a single click, it has smoothened. So like this, you need to smooth, or else you need to do the remesh option. So this is how you need to correct the flow. The important checks are, we need to clear all the F10 quality parameters, and the additional checks are the free edges, normals, and the duplicates, along with the flow lines. All your elements should be within the geometry. Back-to-back trias are not allowed. Trias near the geometry ends also not allowed. See, and the trias near the washers also, we are not supposed to keep anything like that. See, this is not the zigzag. This is called the zigzag. we are not allowed to keep the flow like this. All your elements should be perpendicularly. See, like this, it should be exactly, it should be in a square shape. If not, we should be within the defined range. See here, you can see there are two kinds of elements. Rotating quads, we are not keeping in a crash analysis. We are either it should be like this. If the length is not same, you can go like this. Sometimes what happen, based on the project requirement, the element shape or the element size, or keeping a trias, or holding the number of trias, or restricting the number of trias, it's all depend on the project you are going to work. That means if you are working for the crash analysis, we are not supposed to keep any of the rotating quads like this. The flow should be like this only. The flow, this is the recommended flow. So these are the different types of elements which we are not supposed to keep on the complete meshing. With this, we have learned how not to mesh how not to mesh and all we have learned, and we'll review the component. Okay, I'm switching off the mid surface now. Just I'm switch off all the geometry. I'll switch on only the main CAD. I have assigned the thickness for this component and I'm keeping in a detailed view. Now see, even though I have meshed for the single surface, you can see the now you can see the 3D representation of the element. That means I have assigned the thickness. See, I have assigned the thickness. See this, even though my elements are in the mid plane, after assigning the thickness, your component should look like this. It means it is matching with the CAD. You are defined a correct thickness. So this is how we need to assign the thickness. We need to clear the quality and everything. And I hope you understand how to do the 2D meshing from scratch to the how not to mesh. It includes with the quality parameters also. And I believe this video is very helpful for you guys. In this video, try to execute the same thing at your end. Thank you. In the tomorrow's class, we are going to discuss about the 3D meshing, where we are going to build the 3D model using the solid elements, using HyperMesh. Thank you.
Thank you, Tara. Thank you for the session.
Yeah.
And there is a question from Mukul Anand.
Okay.
The question is, what's the maximum percentage of trias in the final mesh?
It should be 5%, within the 5% only. We are not supposed to go with the more than the 5% of trias.
Okay, thank you. Guys, any questions? If you have any questions, you can comment.
Regarding this, the 2D module today, if you are having any doubts and all, we can discuss in the chat box.
I think there are no more questions.
Okay.
Okay. So we'll end the session. Thank you, Tara. Thank you for the session. And thank you everyone for joining in through YouTube Live. Hope to see you soon. Tomorrow will be the last day of the session. So tomorrow we'll be providing the certificate to generate, link to generate your certificate. Okay, Mukul has another question, Tara. Okay. How to check the tria percentage?
Like a tria percentage, that is an option in HyperMesh where you can check the number of elements. You need to go for the tool option. There you can check how many number of quads are there and how many number of trias are there. There you can check it.
Yeah. Any more questions, guys? Okay, I think there are no more questions.
Okay.
Thank you. Thank you for the session. Thank you everyone for joining in. Have a good day.